We're going to do some modeling with trig functions now. So basically we're doing some word problems and then writing trig equations and solving some questions or answering some questions that they want us to do. As you ride a Ferris wheel, your distance from the ground varies sinusoidally with time. So that means it's just a sine or a cosine graph. When the last seat is filled and the Ferris wheel starts, your seat is at the, well, it doesn't actually tell us, but our seat is somewhere around here. Okay. So basically what happens is we're not starting at the very bottom in this problem. Let t be the number of seconds that have elapsed since the Ferris wheel starts. So this will be our t equals 0 point. You find it takes 3 seconds to reach the top, and the wheel makes a complete revolution every 8 seconds. So that means you'll get back to your starting spot at 8 seconds, but that also means you'll get back to the top at 11 seconds. So that's really going to help us a little bit more with the problem, because if I want to graph this, what I'm probably going to want to do is I'm probably going to want to think, okay, I'm at the top at 3 seconds. I'm going to be at the bottom at 7 seconds, which means I'm going to be like directly in the middle on the left and right at 5 seconds and 9 seconds. So that kind of looks like a cosine graph to us, because when time 3 is the case, I'm at the highest point. Then I reach a middle at 5. I get to the bottom at 7. I get back to the middle at 9. Then I reach my highest point at 11. So that kind of looks like a cosine graph. If I look and read the rest of the problem, I see that the highest point is 43 feet above the ground, and the diameter of the wheel is 40 feet. So if that's 43 and this whole diameter is 40, that means I have the bottom height is 3 feet above the ground, which means I'm 23 feet above the ground when I'm at one of these middle 2 points. So now let's write a particular equation that deals with this. Well, this equation, the one that I graphed, is going to be a cosine. So y equals 20. The reason why it's 20 is that my amplitude is 20. From 23 to 43 is 20. Cosine of b, well, I need to figure out what b is. B is 2 pi divided by the period. The period appears to be 8. So b is going to be pi over 4. I have a horizontal shift or a phase shift of 3 to the right. And then my vertical shift is 23. So I have 20 cosine pi over 4 times x minus 3 plus 23. So the italicized questions are kind of guiding us, and I just skipped that. The general equation is y equals a times cosine of b, a cosine b x minus c plus d. So I just kind of filled in what each variable represents. And we already did that in the notes anyway, so you don't need that again. Just look back at the video we did a few days ago. Predict your height above the ground after 6 seconds. So now my job, that doesn't look like a C, looks like a parentheses. Cosine of pi over 4, plug in 6 is my job. So now I have 20 times the cosine of 3 pi over 4 plus 23. So as I do that, I can do this either on a calculator part or a no calculator part. If it was a calculator part, I would just type this in, and I would get y equals 8.858 feet. If this was a no calculator part, I do actually know what the cosine of 3 pi over 4 is. The cosine of 3 pi fourths is negative root 2 over 2. So I could simplify this and give myself an exact answer, which is 23 minus 10 root 2. So I can do this either on a calculator or a no calculator part, depending on what you're given. Problem 2. I have this graphic over here that I got from the National Ocean Service website to help us understand what a crest and a trough are. So the crest is the top, the trough is the bottom, and then we have what's called calm sea level. So the wave height would be from calm, or the wave height is from trough to crest. So when it says 10 feet high from crest to trough, or trough to crest, then that's referring to from the very bottom to the very top. We'll call calm sea level 0 in this problem. So that means it's going from -5 at a trough to 5 at a crest based on that information. And then wavelengths are 250 feet. So we'll start at 0 and go to 250, and then we'll just kind of go from there. So there's our sine graph. So if I'm looking at how much I have to go up by for my intervals when I'm graphing it, that's 250 over 4, and that is 62.5. So I have 62.5, 125, 187.5, and 250. So that's kind of a quick graph of the situation. An equation that models this, well, I just made a sine graph, so I might as well use sine. Y equals 5 sine of, now I got to find b, so b is equal to 2 pi divided by the period, and the period's 250, so it looks like b is pi over 125. And then I had no shift, so I can just write x, and I had no vertical shift, so that's basically the end of the equation. Now I'm going to determine the height of a wave measured 200 feet from the trough of the previous wave. So I could make a whole new equation, but I don't really have to. So what I'm going to understand is, here's the start of a trough at 187.5. 200 feet past that is going to be 200 plus 187.5. I will get the height of this if I just sub in 387.5 to my equation, because that will continue to trace ourselves along, and then I'll end up, I'm drawing blue on blue, that's really not very smart, but I'll end up 200 away from wherever I was, and then that will give me whatever my answer is. So y equals 5 times the sine of 387.5 pi over 125. So I'm subbing in 387.5. And when this would probably be a calculator question. And then I end up with negative 1.545. So in context, what that basically means is that 200 feet from the trough of a previous wave, the height of my wave is 1.545 feet below calm sea level.